Welcome to another episode of Petrochemical Diary. Now today we'll look at petrochemical intermediates for natural gas, the role of natural gas in petrochemical production. Now if you look at my previous video, you will see that the petrochemical is defined. If you look at the definition of petrochemical is a chemical gotten for natural gas or crude oil. Now we have been looking at how we have got our chemicals in a crude oil. Now today look at how we can get our petrochemical intermediates from natural gas as a feedstocks. Now let's dive into it. Now natural gas is a natural occurring mixture of light hydrocarbons accompanied by some non-hydrocarbon compounds. Some of the non-hydrocarbon compounds are weak acids such as hydrogen sulfide and carbon dioxide. Others are inert gas such as argon, helium, nitrogen. Now look at this now. In natural gas, where we got our natural gas, it contains non-hydrocarbon compounds and it also contains our inert gas. It contains non-hydrocarbon compounds such as weak acids such as hydrogen sulfide and carbon dioxide. It also contains our inert gas, which is argon, helium, and nitrogen. It also contains higher molecular weight hydrocarbons present. It also present in natural gas, which are our ethane, our propane, and our butane. So all these are contained in our natural gas. So today we will look at how we can actually got our intermediates from our natural gas. Now, for example, ethane may be separated for a feedstocks for steam cracking from the production of ethylene. Our natural gas, it contains hydrogen sulfide and carbon dioxide. The hydrogen sulfide and carbon dioxide will be separated. Then our argon, helium, and nitrogen also. Then our higher molecular weight hydrocarbons, which are ethane, propane, will work on them to produce our petrochemical intermediate. For example, our ethane may be separated for a feedstock from steam cracking for the production of ethylene. For the production of ethylene, then we've gotten our intermediate. Then we polymerize ethylene to produce our polyethylene. That is one importance of petrochemical intermediate. So our petrochemical intermediates obtained from natural gas are ethylene, and like I said, propylene. Propylene is gotten for our propane. Our propane is in natural gas. So our butadiene gotten for butane, our methanol, and our ammonia. Now, natural gas treatment process. Now, to get a pure natural gas, to get a pure natural gas used in the petrochemical industry, we have to treat it. We have to treat the natural gas. Now, if you look at my previous video, if you have not watched it, please go and watch it. I talk about how we can treat our crude oil. How we can treat our crude oil before taking it to the refinery. Now, also natural gas can still be treated. We still treat natural gas. So I said natural gas contains hydrocarbons. It contains hydrocarbons and non-hydrocarbons. Like the non-hydrocarbons, we have our carbon dioxide and our hydrogen sulfide, and also it also contains water vapor. Now this carbon dioxide and our hydrogen sulfide must be separated because our carbon dioxide is poisonous. Carbon dioxide is poisonous. Now the major material for the petrochemical processes comes from natural gas, I said, and by composition, natural gas consists of different hydrocarbons such as our ethane, our propane, which is used for our butane. All these are useful in the petrochemical industry. carbon dioxide, hydrogen sulfide, and water vapor. Now, the presence of hydrogen sulfide in natural gas cannot be tolerated because it is poisonous. That is our hydrogen sulfide. It is poisonous. It also corrodes metallic equipment. So our hydrogen sulfide is poisonous and it also corrodes metallic equipment. That means it leads to corrosion of equipment, lead to corrosion of pipelines or of pipe. So it lead to corrosion of some of the tanks used in our industry. So this hydrogen sulfide must be separated by treating natural gas. Now, the presence of carbon dioxide in natural gas reduces the heating value of the gas and solidifies under the high pressure and low temperature used for transporting natural gas. Now, the presence of carbon dioxide in natural gas it reduces the heating value of the gas. It reduces the heating value of the gas. Therefore, it must be removed, must be treated. Now, to obtain a sweet or dry natural gas, acid gases must be removed and water vapor must be removed. To obtain a sweet natural gas, acid gas must be removed and the water vapor also must be removed. Now let's talk about the acid gas treatment. So how can this acid gas be removed? What is acid gas? First of all, acid gas is a natural gas that contains significant amounts of acidic components, most commonly hydrogen sulfide and carbon dioxide. Now you see the presence of hydrogen sulfide and carbon dioxide in our natural gas make it an acid gas, and this acid gas must be removed. These acid gas are purified or removed in three methods. Number one method we have in removing this acid gas is physical absorption using a selective absorption solvent. And we have our physical adsorption using a solid adsorbent. Now also the last one is chemical absorption, where a solvent or a chemical is capable of reacting reversibly with the acid gases. So let's look at them after the other. What is physical absorption? So what is absorption? First of all, absorption is the process of removing acid components such as our hydrogen sulfide and carbon dioxide for a gas stream by bringing it into contact with a liquid solvent that can selectively dissolve these components. Now this absorption is the process of removing acid gas, as I said, hydrogen sulfide and our carbon dioxide make a natural gas and a acid gas. So absorption is the process of removing this acid gas components from our gas stream by bringing it into a contact with a liquid solvent that can selectively dissolve these components. Now the important processes commercially used are the Celloso process, the Sulfino process, and the Retiso processes. In these processes, the solvent, which is the adsorbent, as we said, our absorption is the process of removing acid gas component for our hydrogen sulfide, removing our hydrogen sulfide and our carbon dioxide for a gas stream by bringing it into a contact with a liquid solvent. So we are bringing it into a contact of our liquid solvent. Usually it's a liquid solvent that selectively absorb. So the liquid solvent selectively absorb the acid gas and leave out the hydrocarbons. So the liquid solvent it absorb the acid gas and the hydrocarbons is left behind, like our high molecular hydrocarbons, our ethane and our propane and our butane. All those they are left behind that is used in our petrochemical industry. Now for example in the Celloso process, the solvent is dimethyl ethyl or of polyethylene glycol. Now the solvent used in the Celloso process is dimethyl ethyl of polyethylene glycol. When the solvent becomes saturated with the acid gases, the pressure is reduced and hydrogen sulfide and carbon dioxide are absorbed. The solvent is then recycled to the adsorption tower. Let's move to the next one. Physical adsorption. Physical adsorption is in acid gas treatment is a process where acid gas molecules such as our hydrogen sulfide and carbon dioxide said adhere to the surface of a solid adsorbent due to weak physical forces, mainly van der Waals forces, without forming chemical bonds. And you see, in the process of our physical absorption, we use solvents, which are liquid. Now, in this process, now the process of physical absorption, we are using solid adsorbent. Now, the solid adsorbent, they said they adhere to the surface of a solid adsorbent due to the weak physical forces. Now, in the physical absorption, they absorb the acid gas, while in this our physical absorption, they adhere to the surface of the solid adsorbent. This occurs due to the weak physical forces, mainly the van der Waals forces, without forming chemical bond, without reacting with the chemical. Now, in these processes, a solid with a high surface area is used. Molecular sieve, such as zeolites, are widely used and are capable of absorbing large amounts of gases. More than one absorption bed is used for continuous operation. One bed is in use while the other is being regenerated. So let's look at the last one, chemical absorption or chemisorption. Now, chemical absorption or chemisorption in acid gas treatment is the process where acid gases such as hydrogen sulfide and carbon dioxide are removed from a gas stream by dissolving them into a liquid solvent that reacts chemically with them. Now, in our physical absorption and in our physical adsorption, the chemical does not react with them, with the solvent or with the solid. But in this our chemical absorption, the chemical reacts with them. Now, in the process of chemical absorption, is the acid gas such as the nitrogen, the hydrogen sulfide and carbon dioxide are removed from a gas stream by dissolving them. They are dissolved into a liquid solvent that react chemically with them. Now, in this process, they use a solution of a relatively weak base, such as monoethanol amine. The acid gas forms a weak bond with the base, which can be regenerated easily. And the acid gas, which is our hydrogen sulfide and our carbon dioxide, they form a weak bond with the base, which can be regenerated easily. Monodimethyl amine and are frequently used. Mono and dimethyl amine, they are frequently used liquid in doing this. This is the most common method used in natural gas sweetening or in natural gas treatment because it can handle large volume of acid gas and produce very pure treatment. Now, we have looked at our physical adsorption in acid gas treatment, and we have looked at our physical adsorption and chemical adsorption in acid gas treatment. Now, when the acid gas is treated, when the hydrogen sulfide is removed and our carbon dioxide is removed and also our water is removed for the gas. Now, we have our higher molecular weight gas, which are ethane, our propane, our butane. So all those, they are useful in our petrochemical industry, used to produce our petrochemical products. Like example, like we said, our ethane is we are ethane more processing. We produce our ethylene. For our ethylene, we have our ethylene polymerized. We produce our polyethylene, which is our plastics, whether our linear low polyethylene or our linear low density polyethylene or our high density polyethylene. So all these products are useful in our petrochemical industry. So we have looked at how we can cut our petrochemical intermediate from our gas by treating our gas. So thank you very much for watching. Like my YouTube channel and share and subscribe.